I think we are live. So let's quickly get on with the discussion for today. So we're going to be starting out with some really tricky problems that are tested on the exam. And these questions invariably take people about 2.5 to 3 minutes to get the answer. And even when they do get the answer, typically there is some confusion with respect to whether they've got the right answer or not got the right answer. So we'll discuss the best approaches to tackle these problems and also the traps. Avoiding those traps is really important to score a 740 plus on the GMAT. So let's quickly get on with the discussion. I'll be taking a few questions that don't require any background whatsoever. So for instance, if you look at this question right here, this question is n by 18 an integer? So it says 5n by 18 is an integer. So the question that you should ask yourself is that if this information is true, that if 5n by 18 is actually an integer, is it really necessary? Is it really necessary that n by 18 has to be an integer? Right? If you think about it, if 5n by 18 is an integer, is it really necessary that n by 18 has to be an integer? Now, a lot of the times when people are approaching a question like this, they end up assuming that n can only be multiples of 18. They feel that okay, since 5 does not cancel out 18 in any way, must have something to do with 18 in order for it to be able to cancel out the denominator. So the instinctive response here is that people assume n has to be a multiple of 18. And that is why they sometimes end up going wrong on a question like this. What is really important here is to understand that n could be a fraction. Think about it. If I say 5n by 18 is can't 5n by 18 be any integer? Can't 5n by 18 be 1? Can't 5n by 18 be 2 or 3 or 4 or 5 or 6? And if I were to consider just one number here, let's say 5n by 18 is equal to 1. In that case, you get n to be 18 by 5. And if you get 18 by 5 and you plug it back into the question, you realize n by 18 will then come out to be 1 by 5, which is not an integer. So the number one trap to avoid on data sufficiency, something that's tested to varying extents on every single question in DS, is the assumption trap. That's the number one trap to avoid, where you basically start assuming that x could only be, let's say, positive numbers, or x could only be negative numbers, or they can only be integers or only fractions. If there is nothing given about the variable, please understand it is free to assume any value on the number line. So if 5n by 18 comes out to be equal to 1, in that case you get n to be 18 by 5. To plug it back into the question, you'll get n by 18 to be 1 by 5, which is not an integer. On the other hand, if you take 5n by 18 to be equal to 5, in this case you'll get n by 18 as equal to 1, which is an integer. So I'm sure you can see that you're getting a contrast. 1 by 5 is not an integer, and here 1 is an integer. So clearly the first statement on its own is not going to be sufficient to answer this question. And I believe if you understood this particular approach for the first statement, you can simply extrapolate from there and answer the second statement on your own, right? If you look at the second statement over here, second statement is 3n by 18 is an integer. And if you want, as I said, you can extrapolate and understand that 3n by 18 could be any integer. 3n by 18 could be 1, 3n by 18 could be 2, 3, 4, 5, 6. It could be any integer. So if I were to just take 3n as 1, let's say, right? If I take 3n by 18 as 1, in that case, you'll get n equals 6. And if you get n equals 6 and you plug it back into the question, you get n by 18 as 1 by 3, which is obviously not an integer. On the other hand, if I take 3n by 18 to be another integer, let's say 3, in this case, you'll get n to be 18, and n by 18 will come out to be 1, which is an integer. So what is really important here is that even though I am satisfying the condition given in the question, given the second statement, in each of these cases, you can see in each of these cases, I am taking 3n by 18 to be an integer. Even though I'm taking 3n by 18 to be an integer in each of these cases, I'm getting conflicting answers for n by 18. In some cases, it's coming out to be yes, it is going to be an integer. In some cases, it's going to come out to be no, it can be even a fraction. So both the statements, as you can see, at least individually, are not sufficient to answer the question. Once you've reached this step where you've understood that both the statements are individually not sufficient, then the next thing is to actually combine the two and then test out. When you talk about combination, again, a lot of people jump the gun here and they start plugging in values directly. I would recommend that before you plug in the values, please explore if there is a way for you to simplify the two statements in any way. When you talk about simplification, generally the easiest way to kind of think about simplification is to think of any one of the four basic arithmetic operations. You've got addition, subtraction, multiplication, and division, right? You've got any one of these four basic arithmetic operations. If you were to apply, you should be able to get the answer. But the point is, you need to be looking at the most efficient out of these four possibilities. So run through the possibilities in your head. If you were to divide the two statements, you'll end up canceling out n altogether. If you were to multiply the two statements, you get something in terms of n square. If you subtract the two statements, you get something about 2n by 18. And if you add the two, you get 8n by 18. So you can do this all in your head. You don't really have to pick up your pen for this. Now, out of all of these, understand which one would be the most efficient out of all of these. If you divide the two and you end up canceling out n, you realize it's not a very smart move. And the reason it's not a smart move is because you can see that the question has n in it. We want to figure out something about n by 18. So if you were to use an approach that ends up canceling out n altogether, not a very smart move. If you were to multiply the two, you'll get something in terms of n square, which again is going to just make things more complex, not simpler. If you were to subtract the two, you're going to get something in terms of 2n by 18. And if you were to add the two, you'll get something in terms of 8n by 18. And I'm sure it's a no-brainer at this point to understand which one is the easier of the two expressions, easier to simplify out of the two expressions. Clearly 2n by 18 is easier to simplify. If 2n by 18 is easier to simplify, then you roll with it, right? On the GMAT, it's not just about getting the right answer, it's also about getting the right answer within the stipulated time. So although you'll get the right answer using 8n by 18, it's just that it might take you 10-15 seconds extra. And why would you want to waste that? So if you simply just subtract the two statements, you'll get 2n by 18 is an integer, because one integer minus another integer has to be an integer. Now what do we have? Again, only plug in values when you're absolutely certain there is no more scope for simplification. As you can see, there is still some scope for simplification. How can we simplify it even further? This is what we have deduced after subtracting the two statements, whereas 3n by 18 is already given to us in the question. So if I were to go ahead and subtract these two yet again, if I subtract 2n by 18 from 3n by 18, you understand I'm going to get n by 18. And on the right hand side, I'm going to subtract one integer from another integer and get an integer here. Now, slightly unconventional in the way we are going about this, but the fact that you don't really have to test numbers, it really gives you the confidence that n by 18 is guaranteed to be an integer. This is an algebraic way to reach the conclusion that n by 18 has to be an integer. There are no two ways around it. So you get a confirmed answer after combination. You don't get there with any of the statements individually. So the takeaway from here is only plug in values when you're absolutely certain there is no more scope for simplification. If there's even a slight scope for simplification, jump onto that chance, jump onto that opportunity, simplify, and then plug in the values if required. Right? So for the first statement, the answer is going to come out to be C, which is that the combination is sufficient to answer the question.